Hello students, today we see chapter number 12, Aldehydes, Ketones and Carboxylic acids. Preparation of carboxylic acids and physical properties. Preparation of carboxylic acids from nitriles and amides. Alkyl or aryl nitrides on acid hydrolysis gives amides, which on further acid hydrolysis gives corresponding carboxylic acids. General reaction RCN plus H2 gets converted into amide RCONH2, which is on acid hydrolysis gives carboxylic acid, that is RCOOH plus NH3. IUPAC names of nitriles is alkane nitrile. Acetonitrile on acid hydrolysis gives amides, which on further acid hydrolysis gives acetic acid. Reaction CH3CN ethane nitrile plus twice of H2O plus dilute HCl, it gets converted into CH3COOH ethanoic acid, that is acetic acid. Second, from acyl chloride and anhydrides. Acyl chlorides on hydrolysis with water gives carboxylic acid. Reaction RCOCl plus H2O gets converted into RCOOH plus HCl. IUPAC name of acyl chloride is alkanoyl chloride. Reaction CH3COCl ethanoyl chloride plus H2O gets converted into CH3COOH ethanoic acid plus HCl. This method is useful for the preparation of aliphatic as well as aromatic acids. Similarly, C6H5COCl benzoyl chloride gets converted into C6H5COOH, that is benzoic acid. Anhydrides on hydrolysis with water gives carboxylic acids. Reaction RCOOCOR plus H2 gets converted into 2 molecules of RCOOH. Reaction CH3COOCOCH3 ethanoic anhydride plus H2 gets converted into 2 molecules of acetic acid. From esters. Acid hydrolysis of esters. Esters on hydrolysis with dilute mineral acid like HCl or H2SO4 gives corresponding carboxylic acids. RCOOR' plus H2O in presence of dilute H2SO4 gives RCOOH carboxylic acid plus ROH. IUPAC name of ester is alkyl alkanoate. Reaction CH3COOCH3 plus H2O in presence of dilute sulfuric acid gets converted into CH3COOH ethanoic acid plus CH3OH methanol. Alkaline hydrolysis of ester. Ester on hydrolysis with dilute NaOH or KOH form water-soluble sodium or potassium salt of acid. On acidification with concentrated HCl, free acid is formed. Reaction C2H5COOCH3 plus dilute NaOH, it gets converted into C2H5COONA sodium propanoate plus CH3OH. Sodium propanoate on hydrolysis in presence of acid gets converted into propanoic acid, that is C2H5COOH plus NaOH. The sodium or potassium salt of higher fatty acids are known as soap. Hence, alkaline hydrolysis of ester is called saponification. From alkyl benzene. Aromatic carboxylic acids can be prepared by oxidation of alkyl benzene with dilute HNO3 or alkaline or acidic cheminophore or chromic acid. Reaction toluene on cheminophore KOH, it gets converted to potassium benzoate, which is on acid hydrolysis gives benzoic acid. The entire alkyl chain, regardless of its length, is oxidized to carboxylic acid. Cumene gets converted into potassium benzoate, which is gets converted into benzoic acid after acid hydrolysis. Tertiary alkyl group is however not oxidized. From alkenes. Carboxylic acid can also be prepared by the oxidation of alkenes by cheminophore in dilute H2SO4. Reaction C6H5CH double bond CH2 In presence of KMnO4 and dilute H2SO4 gets converted into C6H5COH, that is benzoic acid. Similarly, cyclohexene gets converted into adipic acid. From Grignard reagent. Grignard reagent is added to solid carbon dioxide, that is dry ice, in presence of dry ether to give a complex which is on acid hydrolysis gives corresponding carboxylic acid. General reaction RMgX plus CO2 in presence of dry ether, it gives complex which is on hydrolysis in presence of acid gets converted into carboxylic acid. Reaction ethyl magnesium chloride, that is CH3CH2 MgCl plus CO2 in presence of dry ether, it gives magnesium complex which is on acid hydrolysis gets converted into CH3CH2COH, that is propanoic acid plus MgOHCl. Physical properties. Nature of intermolecular forces. The carbonyl bond in aldehydes and ketones is a polar covalent bond. Thus, these compounds contains dipole-dipole force of attraction. Here, presence of partial positive and partial negative charge on carbon and oxygen in carbonyl compounds. Carboxyl group of carboxylic acid contains OH bond. This carboxylic acid exhibit hydrogen bonding. Physical state of aldehydes and ketones. Formaldehyde is a gas at room temperature and has irritating odor. Acetaldehyde is extremely volatile, colorless liquid. Acetone is a liquid at room temperature and has a pleasant odor, but most of the higher ketones have bland odor. Boiling points. Boiling points of the organic compound, that is aldehydes, increases with increasing number of carbon atoms. Solubility of aldehydes and ketones. The oxygen atom of carbonyl group can form hydrogen bond with water molecules. Here, general reaction formation of hydrogen bonding in carbonyl compound and water. Hence, lower aldehydes and ketones are water soluble. As the molecular mass increases, the proportion of hydrocarbon part of the molecule increases and solubility in water decreases. Physical state of carboxylic acids. Lower aliphatic carboxylic acids up to 9 carbon atoms are colorless liquids with irritating odor. The higher homologous are colorless, odorless, wax-like solids. Boiling points. Boiling points of carboxylic acid increases with increasing molecular weight because there is increasing number of carbon atoms. Comparing boiling points of carboxylic acids with other families of organic compounds. When we consider alkanes and aldehydes, then boiling point also goes on increasing with increasing molecular weight of the organic compounds. Carboxylic acids have higher boiling points than those of alkanes, ethers, alcohols, aldehydes, and ketones of comparable molecular masses. In liquid phase, carboxylic acid form dimer in which two molecules are held by two hydrogen bonds. As the size of the molecule is doubled, the strength of intermolecular van der Waals force increases, which results in higher boiling points. Solubility of carboxylic acids. Lower aliphatic carboxylic acids up to 4 carbons are miscible in water. This is due to the formation of intermolecular hydrogen bond between acid and water molecules. Higher carboxylic acids are most insoluble in water. Aromatic acids are also practically insoluble in water at room temperature. Water insoluble acids are soluble in less polar solvents like ether, alcohol, benzene, etc. Thank you.